Hi, Chris Kuzmal here. We're now going to look at the test case for a sort of a general test case for deletion for binary search trees. And this really shows, I think, between this and the intricate code for testing deletion for the rotate out method, that testing is really as, if not really, it's more sophisticated and more complex than writing the original code. Test delete many begins by establishing a binary tree, but then we also create an array list of integers, which are going to contain our expected values. It's empty, and we establish a test size of 64. We could vary this test size, and we could possibly even parameterize our tests so that we could specify the size of the test. But I go ahead and just set it as a variable equal to 64. And all I do is I iterate through. Now, this is a little bit simpler in structure in terms of for loops than the rotate out test method, but it is more complex in the sense that it invokes the math.random method to generate a key. We multiply test size by math.random. Any reasonable value for the multiplier here would work okay to generate a sequence of random values that become our keys. They're all going to be random integers, and we then insert that key into our tree. We also insert that key into our array list. We then invoke a second library function for collections.sort, which sorts that array list. This is useful because, of course, a binary search tree, when we extract it using a sorted key array list function down here, or method down here, then it's going to produce a sorted sequence as well. So the sorted sequence that comes from having done the sort on line 202, and the sorted sequence that comes from having done the sorted key array list on line 207 should produce the same two array lists of integers which have the same values. And the good news is that the equals method will accurately compute whether or not we've succeeded in doing that. And of course, the deletion operation is going to be simply that we delete the same element that we deleted from the array list. And what we do is our loop starts at 0 and iterates through the test size. And this is just a remove count. We don't actually use remove count inside the loop, because when we remove an element from the array list, we can just remove element 0 repeatedly, and the array list gets rid of element 0, and there's going to be a new element 0 that we can remove, and that becomes the remove value, which we then use to look up through the search function for the binary search tree to identify which node we want to remove from the binary search tree using delete. And so that's this sequence on lines 204 removes a particular value, the 0th value, from our array list, and determines which node to remove from our binary search tree. And having deleted the same elements from each tree, we produce the sorted key array list for our binary search tree and compare that sorted key array list to the array list that we are operating with on a running basis, and they should be equal, and that produces a pass. And so on each iteration, we are effectively doing a test, and as we can see over here, we pass all. I gotta adjust this thing over this way. We pass 89 tests. Many of those tests are done here, 64 of them, in fact, because our test size is 64. And so that's the structure of the test delete many test case, and rounds out our test cases, I believe, for binary search trees. We're now going to move on to red-black trees.